I like to write it. This one's written top to bottom just because of the nature of the table. But when I'm doing conversions, I always put the base unit in the middle, and then I put my units going down. See, I do it like the decimal system. So it's always like deci, centa, milla. And basically, if you think about the way that our decimal system works, this essentially works the same way. So it's like to get to decimeters, that's like dividing by 10. To get to centimeters, it's like hundredths of a meter. Millimeters are like thousandths. It lines up with the decimal system really nice. And then going up, there's decameters, that's 10 meters put together. There's hectometers, that's 100 meters put together. And then there's always kilo at the top, which is 1,000. All right? And because it lines up so nicely with our decimal system, doing conversions within metrics is really easy. All you got to do is figure out, okay, well, what unit are we starting in? What unit do we want to go to? And then the little diagram shows you which way to move your decimal. So, like we're starting in meters, right? And I'm trying to convert it to centimeters, so we can just take that decimal and move it over 1, 2. Essentially what we're doing is we're multiplying by 100. But because it corresponds with the decimal system, converting in the metric system just involves moving the decimal place. So 1.85 meters, to get to centimeters, all I have to do is move my decimal place over 2 places to the right, and that would be 185 centimeters. So 1.85 meters is the same as 185 centimeters. Then if you wanted to convert it the other way, so let's say we wanted to convert, say, 1.85 meters to kilometers. All right. We just go back to our chart and we say, okay, we're starting at meters, and where are we trying to get to? Kilometers. So we're going to go 1, 2, 3 to the left. 3 place values to the left. So we pick that decimal up and we go 1, 2, 3 to the left. Now what do you do if I'm moving my decimal over here? What do I do in the spaces in between? We just fill them in. Okay. So this is how you convert within meters. Sorry. Yeah? So so if you're doing within metric, it's not too bad. I take that chart and just rearrange it left to right. You can do it with top to bottom. It's always basically whatever unit you're in and whatever unit you're trying to get to, that's how many decimal places you move it. And then the direction just depends on whether you're trying to go up or down. The nice thing, though, is if you know how to do it in lengths, you also know how to do it in all the other systems as well. So let's say, for example, let's go delete here. So let's say, for example, that let's go with milligrams or something. Okay, so let's say that a dose of medicine is, I don't know, like 75 milligrams. And I want you to convert that to grams. All right. So the nice thing about it is it stays the same, right? There's this base unit, that's the gram, and then it always goes deci, centa, milla, as you're getting smaller, and it goes deca, hecta, kilo, as you get bigger. Okay. So milligrams, like the smallest measurement system. Well, it's like the smallest we're going to talk about. You can get smaller, but all right. So then we're at milligrams, and I'm trying to get to grams. So which way does my decimal need to go, and how many places? Yeah, it needs to go 1, 2, 3 to the left, because I'm at milligrams, want to get to grams. So my decimal place with the whole number, the decimal is at the end of it, right? So I need to pick it up and go 1, 2, 3 to the left. And so it's going to be 0.075 grams. Okay. Make sense? All right. If you got, let's say, same with liters. Like, let's say that a household uses 1.7 kiloliters per month, and I want to convert that to just liters. So now we're over looking at the volume or capacity side. But again, it's always the same. Like the process is the same. The liter is the base unit, and it always goes deci, centa, milli, or it goes deca, hecta, kilo. So in this case, we're starting at kiloliters, so we're up there at the top. And I want to move it into liters, which would be, 1, 2, 3 decimal places to the right. So I take that decimal and go 1, 2, 3 to the right. And so you'd be looking at 1,700 liters. Okay. So far, so good? Any questions about those ones? So conversions within the metric system are really nice because essentially all you got to do is move your decimal place around. It's pretty straightforward. Okay. Now, that's great, except for most of the time when we encounter measurements, you encounter in the U.S. customary units or the U.S. system units. And so conversions with U.S. units are a lot more annoying. So I'm going to show you how to do that now. Okay. So in the U.S. system, what the most procedural way to do it is something called unit canceling. So there's some conversion rates on there, like weights, lengths, things like that. So, for example, okay, let's say, I know that if you look at an American football field, so American football field is 120 yards from end to end. So 100 yards of play, 10 yards on each end zone. So 120 yards end to end. And let's say I wanted to convert that to feet. All right. So how would you convert? Now, you might actually know how to do this one without having to set up anything fancy, because how would you solve this problem? How do you go from yards to feet? Anybody know? How many feet are in a yard? 3 feet per yard? So if there's 3 feet per yard and we got 120 yards, what should we do to find the number of feet? Close. Flip it. Flip that operation. You'd actually multiply it. Okay? There's actually a stretch. So you do end up multiplying it, right? Because if there's 3 per yard, that means every single yard has 3 in them. So there should be more feet than yards in a football field, right? Like it would take more rulers to measure a football field than it would yardsticks. Now, there's this process that you can use, and this is going to help us in converting between systems too. I call it unit canceling. So here's the way it works. Okay. So first off, you say, okay, where are we starting? We're starting at yards. Okay. Then what you do is we're going to use a fraction. We're going to multiply this by a fraction. And the fraction we're going to use is we're going to use the ratio or the rate fraction that compares the unit we're in to the unit we're moving to. So I want to get rid of yards. So what I do is I put my yards on the bottom because I'm trying to get rid of yards. But what I want to keep is feet. All right? You with me? Then with the fraction, you just put the conversion rate in there. So like for yards, what do we know? We know that 3 feet make 1 yard. And the reason, so then the fraction actually tells you whether you should multiply or divide to make the conversion. Because here, like our yards, the units cancel. Like yards divided by yards, the units cancel out. So the only unit you're left with here is feet. Then you can see here that the 3 is in the numerator. So this becomes you have 120 times 3 on top, and you just have a 1 in the bottom. So this just becomes a multiplication problem. So you can see that the answer is going to be 120 times 3, which is 360 feet. Okay. So the unit canceling method helps you understand whether the right decision would be to multiply or to divide. Okay, so then, for example, we know that the football field, the nice thing about, let's say football, we know now that it's 360 feet. What if I wanted to convert that to miles? And let's say we're going to round to the nearest hundredth. Okay. So we know how long it is in feet now. Now I want to figure out, well, how much. So if I run down a football field, what portion of a mile have I run? It's not going to be a whole mile, but it'll be some fraction of a mile. All right. So then how would we do that? So you go back to your you go back to your conversion table. How many feet are in a mile? 5,280, because why not? I don't know, but that's just the rule. So then how do we convert that into a mile? Multiply or divide? It's going to be division. How do you know it's going to be division? Well, one way to figure out, you can kind of sort of reason it out. Because if you multiply 360 by 5,280, you're going to get some ginormous number, right? Can a football field possibly be like 15,000 miles long? No, right? So you could multiply it and you could see that the answer would be like garbage. It doesn't make any sense. So then you know that dividing would probably be the right answer. But if you use unit canceling, it actually helps you figure out what to do. So what am I trying to do? I'm trying to get rid of feet. So I put feet in the denominator because I'm going to get rid of that unit. What am I trying to get to? I'm trying to get to miles, right? Well, what's the conversion rate based on our table up here? It says that 1 mile is 5,280 feet. So you see in this case, the 5,280 goes on the denominator because that's the unit we're trying to get rid of. So the units, the feet unit will cancel out. And so we're just going to have 360 times 1 on top, so that's just 360. And then we're going to divide by 5,280. And feet's our only unit left. So then it's whatever 360 divided by 5,280 is. Feet were gone. That's the unit we got rid of. The unit that was left was miles. So we're doing a divide. So what do you get if you divide that? 360 divided by 5,280? 0.068. So 0.068 ... and I said round to the nearest hundredths. So that would be like 0.07 miles. So it's like a little less than a tenth of a mile. So you have to run up and down a football field quite a few times to run a mile. All right? Questions about either of those? You're going to end up multiplying or dividing. It's going to be one or the other when you make the conversions. But it's just sometimes it's hard to figure out whether you should do one or the other. And if you can't figure it out, the unit canceling helps you understand which operation to do. That's the idea. Okay, so let's go Let's try another. Let's try another example. You can actually do, the nice thing about unit canceling is it allows you to even go through, you can convert through multiple units at a time. So like we started at yards. So it's 120 yards. If we wanted to convert that to miles directly, then you can do that so it's like you're starting at yards. You could get rid of yards and go to feet, because 1 yard is 3 feet. And then you can turn around and you can go from feet to miles, because 1 mile is 5,280 feet. So the unit canceling procedure will actually allow you to go through multiple units at a time if you need to. And it'll get you straight to the right answer. Because see, in this case, so the yards will cancel out in the first multiplication. The feet will cancel out in the second multiplication, and you'll just be left with miles. In the numerator, you have 120 times 3 times 1, and then in the denominator, you have 5,280. So essentially, you just do all your calculations at one time, because on top you'll get that 360. Then you divide it by 5,280, and then that would get you back to the same answer that we got by doing it in 2 steps. So the unit canceling can allow you to go multiple conversions. It allows you to do multiple conversions at a time, basically. That's the advantage. Which is nice when you're trying to make a more complicated conversion. All right? So I'll give you an example. Does everybody kind of see how that worked? Any questions about how I did it up there? We already did that in 2 steps, but you can shortcut it into 1 step if you need to. All right, so let's say, for example, let's say that a container of milk is 1 quart. Let's say you have a 1 quart container of milk, and I want to convert that to, say, fluid ounces. How many fluid ounces are in a quart? All right. So what you can do is, you can see on there's a lot of steps that you have to take to get from quarts down to fluid ounces. And so if you do unit canceling, you can do them all at once, right? So if you're at 1 quart, okay, if you look at that table, well, what's the conversion they give? If we're working our way down, what do they tell us? They tell us that a quart is what? 2 pints, right? So we could get rid of quarts and move to pints if we want, because 1 quart is 2 pints. So that would get rid of our quarts and get us into pints. But then we don't want to stay in pints. What do we want? We need to go from pints down to cups. So we put our pints on bottom. That'll get rid of pints, get us to cups. So 1 pint is 2 cups. But cups isn't, so if we stop there, we would get cups. But we don't want to stop at cups. I'm trying to get down to fluid ounces. So I'm going to get rid of cups and go to fluid ounces. And what's the conversion rate? 1 cup is 8 fluid ounces. So you can go multiple steps within one conversion. So then we can see quarts cancel out in your first multiplication. Pints cancel out in your second multiplication. Cups cancel out in your last multiplication. The only unit that you have left is fluid ounces. And now on the numerator, we have what? 1 times 2 times 2 times 8. And then the denominator, we just have 1 times 1 times 1. So this one ends up being all multiplication. No division needed for this one. Okay. So the numerator, 1 times 2 is 2 times 2 is 4 times 8 is 32. And then downstairs, we just have 1. And so it looks like the answer is just 32 ounces in a quart. So, yeah.
Where do you get those fractions from?
They come from the conversion rates on your table, right? So in each step, I'm trying to get rid of a unit and get closer to the unit I'm working towards. So if you look in our table, like we're at quarts, and we need to work our way up to the ounces. So in the first, I can get rid of quarts and go to pints because I have that conversion rate. So I do that first. But then I don't want to stop at pints, so I can go from pints to cups. But I don't want to stop there either, so I'm also going to go from cups then to fluid ounces. So in each step, whatever unit you're trying to get rid of, you put on the bottom, and the unit you're trying to keep goes on the top. Okay? Yeah? Seem reasonable?
Say that one more time.
So whatever unit you're trying to get rid of, you goes on the bottom. So that's why in my first fraction, I put quarts on the bottom, and then I went to my table and I figured, okay, well, what rate do I have on my table that involves quarts? Well, 1 gallon is 4 quarts, but that doesn't help me because I'm not trying to go up to gallons. The other rate I have there is that 1 quart is 2 pints. That gets me moving in the right direction. So the first thing we did is we moved to pints. And then I just worked my way from there. And you can see in each step, the next fraction that follows is getting rid of the unit before it. Do you see what I mean? Yeah. Should we try another? Okay. All right. So let's say, so for example, let's say, so they have like something called like a 1.5 ton truck, which it doesn't exactly mean this, but more or less, a 1.5 ton truck, it can carry a load of 1.5 tons. That's more or less how they work. Like it can, you can put 1.5 tons on it of weight. You can haul more than that, but that's how much like physical weight you can actually pile on the truck. Okay, so it's like the combined weight of like whatever you have in it, which however much the trailer that you're weighing has the tongue. Anyways, but that's more or less the point. Okay, so then my question is, how many pounds is that? How many pounds can it carry? Okay. So if you go and you look at the weight conversions, what do we know about tons to pounds? Yeah, a ton is 2,000 pounds. So is this going to be a multiplication problem or a division problem? Let's see. So we're starting at tons, right? So when I pick the fraction to multiply by, I want to get rid of tons, so ton goes in the bottom. And I want to move to pounds, so pound goes on top. Okay. Well, how many tons are there and how many pounds? There's 1 ton for every 2,000 pounds. See, we want to keep pounds, so the 2,000 goes in the numerator. So what does this actually become? It actually becomes, oops, that should be 1.5, a multiplication problem. So 1.5 times 2,000 in the top. The only thing left on bottom is a 1. So it's going to be 1.5 times 2,000. So that comes out to be, I think, 3,000. All right. Any questions about that? All right, so it could be multiplication, it could be division. The fractions, the unit canceling, and the fractions help you know which one. Once you know how to do unit canceling, though, then going between systems is really easy using those conversions down at the bottom. So, like, for example, let's say that if you're going to do like a 10K race is 10 kilometers long, and then maybe what you'd like to know is how many miles are in 10 kilometers. All right, so you go down here. There's some conversions in there. So you see there's miles to kilometers. You see that 1 mile, 1.61 kilometers. So then you say, all right, so that's the rate we're going to use. The question is should we multiply by 1.61 or should we divide by 1.61? And that's why we use unit canceling, because the fraction will tell us what to do. So we're starting in kilometers. I want to get rid of kilometers, so that goes on the bottom. That's what I'm trying to get rid of. Then what unit do I want to keep? I want to keep miles. That goes on the top. Then you go down and you look at the conversion rate. And what is the conversion rate? It says that 1 mile is 1.61 kilometers. So the 1 goes on top because it's the miles, and the 1.61 goes on bottom because it's the kilometers, and that's what we're trying to get rid of. So is this a multiplication problem or a division problem? Division. So to do the conversions from kilometers to miles, it looks like you divide by 1.61. So the kilometers cancel out. The only unit you're left with is miles. You have a 10 times 1 on top and a 1.61 on bottom. So this is just 10 over 1.61, which is the same as 10 divided by 1.61. Let's round to the nearest tenth. Okay. What does that come out to be? So 10 divided by 1.61. What do you get? 6.211, you said? Dot, dot, dot. And then if you round that to the nearest tenth, that would be 6.2 miles. So a 10 kilometer run is a 6.2 mile run. About. All right? What do you think? Any questions about why I picked those numbers or why I put the numbers where I put them in the conversion? So this is why the metric system is like a bajillion times better and easier. Why we still use U.S. measurements, I don't know. Just who knows? But that's why we use metric system in science pretty much. Like if you do chemistry or biology, if you ever do any measurements, everything's in the metric system because it just makes things a lot easier to calculate with. So any questions about those ones? So if you're in the metric system, you're just moving the decimal around, no problem. That's not too hard. If you get out of the metric system into the U.S. system, or you try to convert between the two, you don't really have any choice. You basically have to do it with unit canceling fractions like this. Unless you're working with like a function, like if you look at Celsius to Fahrenheit down there, that's a little different because you can literally just plug in the one you have and it'll spit out the one you don't have. So the temperatures are a little bit easier, but everything else and you have to do it basically this way. Because otherwise, sometimes it's not easy to know whether you should multiply or divide. That's the idea. Okay? Okay, so I got some practice for you guys to work on. So I'll give you some of these. These might actually take a while. What I'll do is if you don't have time to finish these, I'll add this to that module for stuff while I'm gone, and then I'll post the solutions up there because there's like 16 problems on here. You might be able to finish them all before we're done today, but I don't know. I don't know where you get through, if you can get through 16 problems and the solutions by 11:30. So just give it a shot. You can ask questions. You can work together. And then I'll post these solutions onto Canvas this afternoon before I leave. That way you'll have access to them. Okay?